Hello guys, welcome back to a new video. In today's video, we're going to start with geometrical meaning of the zeros of the polynomial of the chapter Polynomials class 10th. So let's begin. Now, before jumping to this topic, we must know a few things. That whenever a line intersects x-axis, it the point of intersection the point of intersection is the zero of the polynomial. Okay, as simple as that. And the graph of a quadratic polynomial. Now, in this same topic, geometrical meaning of the zeros of the polynomial, you're going to learn different types of graphs of different types of polynomials, like a constant polynomial, linear polynomial, and quadratic polynomial. Now, in a quadratic polynomial, you're going to have a parabola. A parabola. Now, a lot of students may confuse what is a parabola or what does it look like. So, it's like a U shape. It's like this, right? Wait, it's something like this. It resembles this kind of shape, and it can be from both the sides. It can be like this also. Okay, so this is a parabola where a U shape is formed. Okay, so now let's actually begin the topic with geometrical meaning of the zeros of the polynomial. So first of all, let's talk about graph of constant polynomial. Now the graph of constant polynomial, suppose for example, just for example, let's take x, f of x equal to 4. Okay, or let me give you just a straight example. Now if in any case, if you take a number in a constant polynomial, then suppose this is my y-axis, this is my x-axis, and here is 0 in the middle. Now in a constant polynomial, the line which is formed by the solving of the polynomial that you will get, this will you will learn this in the third chapter actually, where you have to draw these boxes and then graphically represent the equations. Okay, so first you will do the same here. You will put some value of x and y. Once you get the value, some kind of value with y or x, that is your answer. And then you have to plot these. Okay, then you have to plot these. So in a constant polynomial, the lines are always parallel to the x-axis. Now in this case, if the lines are parallel to the x-axis, already I have mentioned this in the starting of the video that whenever a line intersects x-axis, the point of intersection is 0. Okay, I mean whenever line intersects a point, the point of intersection is the 0 of the polynomial. Okay, since this line doesn't intersect y-axis, there is no 0. No 0. Okay, remember this. Now let's talk about graph of linear polynomial. Now, graph of linear polynomial is a bit different from the constant polynomial, because if we take here this imagining graph, this is not up to scale, so don't actually draw this. Draw the proper way using graph paper. Now I'm just telling you, I'm drawing this just for your understanding. Now, in a graph of linear polynomial, if you put any value for suppose any imaginary polynomial, okay, you will get one line, at least one line. Let me draw it with the red pen so you'll understand better. Suppose this is the line. You solve the polynomial, right? And you got the points like this. They're forming such kind of line. Now, where does this point intersect the x-axis? It intersects over here, right? Over here. That's the intersection point. So, according to this graph, okay, and also in general, a linear polynomial will will always have one zero only. Okay, so that's given in your book as well. Okay, now let's talk about quadratic polynomial. Okay, let me give you some value for this point of intersection. Let's suppose this as 3 upon 2. So the 0 of the polynomial of the 0 of the linear polynomial is 3 upon 2. Okay, now graph of quadratic polynomial. Quadratic polynomial. Now, so let's take actually the graph of quadratic polynomial can have n number of zeros as long as it intersects the x-axis. Suppose let's draw two lines over here like this. This is x-axis, this is y-axis, and suppose I draw a graph and and I solve the polynomial and I get some values which form a shape like this. Which form a shape like this. Okay, wait a minute. Sorry. Which form a shape like this. Now let's suppose a graph is formed like this. The graph of quadratic polynomial. Okay, it can be like this also. And there's no limit on how many zeros it can have. So, how many zeros are there actually? So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, and this 10. So these many zeros can be formed. So that's how it is. That's how a quadratic polynomial works. And if you observe very carefully, each of these structures having crests and troughs. Okay, this is the crest and this is the trough. Okay, so these are parabola in shape. You can see parabola even here, even below also. There's a parabola. Even here is a small parabola. You see, that's how it is. That's why a quadratic polynomial will always show a parabolic shape in a graph. Now there's a few things to note about quadratic polynomials. First is the graph is always parabolic. Okay, let me just write that. Graph of quadratic polynomial is always parabolic. Parabolic. Second is if it opens upwards. If it opens upwards, what does it mean? Upwards mean like this. If the graph is like this, then the value of a is greater than 0. Okay, let me write this. If the graph opens upwards, opens upwards, a is greater than 0. Okay, now second is the same. Now just replacing down upwards with downwards. So it will form like this shape. So a will be smaller than 0, like in negative. Okay. Now, what is the actual meaning of a? Now, suppose you're solving a question. Actually, in your book, they might have given a graph, sorry, case-based study. In that, such concept is used. In that, if you get if the parabola is downwards, then the value is negative. Whatever you find, the value is negative. If the parabola is upwards, then the value is positive. You can see because it is greater than 0. If it opens upwards, it is greater than 0, so the value will be positive. Now, if downwards, then it is minus. So, because of the minus, it will whatever answer you find is also minus. Okay, that's it for today, guys. I hope you enjoyed my video, and if you did, please make sure to like, subscribe, and share my video. And in the next video, we are going to start with relations between zeros and coefficients of a polynomial, which is super easy. So the video will be quite short.